Okay, so I was asked about problem 47B, and this has Allison and Adrian. They're connected by a bungee cord that's 30 feet long but can stretch up to 90 feet. And they both start from the same location, and they mention indicated direction. Well, we got to go look for a picture here somewhere. But you know, as they've done in the past with problems, we're going to need positions when we look at this, because it says sketch an accurate picture at t equals 7 seconds. So what we're saying is, well, we want to know where they are at t equals 7 seconds. But there are a couple things. Adrian actually stops moving at 5.5 seconds, so we'll have to figure out where he is. He moves at 8 feet per second. And Allison, though, keeps on moving the whole time. Here's their picture. So I would call the start here the origin, and have Adrian go along the negative x-axis and Allison go along the positive y-axis. And it's going to matter with this building corner, because at some point, if you know Adrian's say right here and Allison is up here, then that bungee cord actually hits that corner, and it doesn't go in a straight line anymore. It goes in a straight line to the corner here and a straight line up to Allison. And so that's why we want an accurate picture at time equals 7. Okay, so I went to Desmos, and so I did Adrian first, and I made a note. And again, the way you make a note is if I just click here and I say, you know, add a note, then the typing looks much better when you do that. So I said Adrian moves 8 feet per second for 5.5 seconds. And so his position, he's going along the negative x-axis. So that's a minus 8 feet per second, actually, as far as direction, times 5.5 seconds. The seconds cancel out. We can see that here, and we'll get our feet. But then the y value is 0. And so I just put it in as a coordinate pair with parentheses. And then I said, well, let's label it and say Adrian. So that's where Adrian is. Now, Allison moves at 10 feet per second all the time. And so, you know, this is her path is 0 and then 10t, depending on what t is. Now, if you type that in, what Desmos does is it automatically makes a parameterization here with t. So if you use t, just like they did in chapter 4, it knows it's a parametric situation, and it does the right thing, sort of. Okay, well, sort of, I say. It's kind of hard to see here, so, you know, if you want to see stuff better, go to bold. And now I can kind of see this blue line, but maybe I'd like a different color line. So I'm going to go here and maybe go with orange or something. I can see that a little better. And now the t is supposed to go up to 7, so I'm going to pause here. Okay, so I think we're going again here. Let me make sure. Yep, we are. Alrighty. And so I can change this to see where Allison gets in 7 seconds by doing that. Now notice it doesn't give me a chance to label it this way, but I could, I guess, go label it that way. just make a point all by itself of 7 times, or 0 and 7 times 10, or 10 times 7, and get that point. But it's right here at this as 70 on the y-axis. And as I look at this, I think that is going to go through the building. It's not going to be on the right side of the building corner. I think the line's going to go through there. So if I check that and I draw a line from the one point to the other, and so here are some things that can help you, just make your life a little easier. So up here, I did Adrian, and I guess I'm gonna call that a lowercase a equals, like that. And you see it still has Adrian there. Now it made it movable. I can change that. That arrows there. I could grab it and move it, but I don't want to. And I could take that away if I go up here to this editing and see it says be able to drag it. Well, I could turn that off so I can't drag it, and then say done. But there I made that A. I'm going to make the building B. Okay, and again, I'm going to tell it not to move, just so I don't accidentally move it. So I'll turn that off here. And then I still need Allison. I'll use an uppercase A for her. Allison, and I will use the 0, comma, and 7 or 10 times 7. Do an asterisk here, makes a single dot. And, I'll label that as Allison.
Good morning.
Oh, let me put you on pause here. Just a second. Okay, we're back off pause, and you'll probably hear some things out from the hall and that kind of thing. But, I spelled this with an I, but I don't know how they spelled it. And again, I want to keep it from moving. So we'll go here. And it can be blue, I guess. Sure. And so, if I were to create a straight line between those 2 points, and actually here's a quick and easy way to do a straight line between a couple of points. And all it does is it sets up parametric equations, but they don't necessarily have the right speed to them. They don't have the right units necessarily. But if I simply take the 2 points and I say, in Desmos, and I say, okay, I'm going to start at little a, that's Adrian. So if I take A and multiply by 1 minus t, so my parameter, and then add to that my other point, A, times t, notice it just do a straight line between those two points, and that's if t is between 0 and 1. If I make it go like from -1, it goes farther. But typically, if I'm doing this sort of thing, I just want to see it for points between 0 and 1 because I want to see where it is. But notice the corner of the building's here. And, so this is a really nice way to do the parametric equations in Desmos, because I can just give you the points. If I give them a name, then I can just do this. And so a more accurate picture, I guess, would be that I have to go from Adrian, little a, to the building, B, right? And so do that, and then go from the building, whoops, I didn't want parentheses yet, so I'll do building and do the same sort of thing, 1 minus t, okay, because it's from the building, and then plus uppercase A times t, and so there we go. That's what the bungee is doing. And so to get the length of the bungee, I need to know the distance from Adrian to the corner of the building and from the corner of the building to Allison. And I've got all those points, so I can just use the distance formula that way. And so, I could do that. I could say, okay, I need the square root and Adrian to the building. So Adrian is at, what the heck was he at? He was at, oh, I never saw what that number is. I could go click on it here, I think. Oh, maybe not. So if I need to know that number, well, just go here and do minus 8 times 5.5, and it's minus 44. And so I need minus 44, and then the building is at minus 20, so minus a minus 20. Squared, and then plus, and Adrian's y value is at 0, so that's 0, minus, and the building is at 30, so 30 squared, and I get 38.41, for that distance there. And then I'd probably do it in a separate spot here and then add the two together. So, I might do something here like say D1 equals, and so there's my D1, and then D2 I'd go from the building up to Allison. Okay, so I've got those coordinates, I can do that. Now I will show you a nice little thing here though too, is actually if I say distance, notice all of a sudden that it was doing all kinds of weird stuff, but as soon as I got the word distance, it wrote it very nicely. If I do an open parenthesis, and I labeled those points, right? I labeled Adrian's point A, well, I define them as little a, and then B, and look at that, what Desmos does. If I give it 2 points, it will actually give me the distance formula this way. So that's a nice thing to know. So if you need to show the distance formula, if you need to write it out, well, you better know what it is. But if you're just kind of calculating distance, or you want to check your work, you can do it like that. And so, we get that distance from here to here. And again, now I'll call this one uppercase D1, because if I call it little d1, it'll be very confused. But then I could do the distance from the building up to Allison. Okay. So that, I think, was really more about 47A. Yeah, what's the length of the bungee at 7 seconds? Now, and then where is Allison when the bungee reaches its maximum length? Okay, so that was what I was asked about. And let's go back to the picture. So at this point, I know that this length here is 38.418, and it's always going to be that because Adrian quit moving. And so at its maximum length, the bungee is 90. And if I take 90 minus D1, I get a distance of 51.58. Okay, so Allison is up here somewhere at 51, at a total distance of 51.58. So now, here's an interesting thing. I could go back to Allison, so here's Allison. And I could go back to allowing Allison to move. And let's see, so I'll go to drag here, and I'll just let Allison move. Oh, it won't let me move it up and down that way. That's interesting. Okay, so I won't do that. I'll just say done and leave it like it was. But, right, if Allison changes, this distance will change somewhere. Oh, the distance from the building to Allison. And so I'm going to do something. This is a nice thing about this calculator. I can do stuff like this. I can grab this and move it down, or I'm going to take this, move it up here so I can see this part, because that's the number I want. And if I do some nifty stuff here, so I'm going to add what we call a slider in. Now we've got this T here, but I'm going to do well, actually, why not do that right here? So I'll get rid of that. And I'm going to make that a T. Okay. And T I can change then, right? I can put it back up to the 7. And, ooh, that did some really weird stuff though. So, that's the thing, doing this stuff on the fly. That could be a problem. So what I was just trying to do is get that distance. So let me, I'm not sure, let's see. Oh, yeah, I see. See, I've got too many T's running around here. That's a problem. And so I'm going to do something slightly different here. I'm going to call this a big T. And it says add a slider. And so now I can grab that and change Allison's position this way. Okay, when it's at 7, we've got that. So the whole point of this was I just wanted to show you a technology way of doing this. I can still do distance, and I can look at the distance between the building and Allison. And so I see that's a distance of 44, but I need to get to a distance of 51. So if I grab the slider here and I just start sliding it up, you see I can get past 51 there's 52, 51.0. So, it's going to be somewhere around 7.7 seconds, right? And I can mess with this. I can even go in here and just like do a 5, and wow, that's really close. So 7.75, is very, very close to the answer. So I can mess with it and get about what the answer is. Okay. Now, so what do you really need to do? Well, okay, we found this 90 minus our distance. Okay, our distance 1. So we took, we took the distance, from Adrian to the building, which was 38. We subtracted that from 90, and we got the 51. And, well, what I know is that Allison needs to be at a point 51 point whatever meters away from the building. Well, Allison, I know, is going to be on the X and Y axis, or sorry, on the Y axis, not on the X and Y axis, on the Y axis. And so I can get her distance, so square root, and her position is going to be, she has a 0, and minus, the building was at minus 20. So square that. And then plus, Allison is going to be, well, I don't know where. She's going to be at some Y value, minus the building, which was at 30, squared. And I know that distance needs to equal, well, 90 minus D1. And see, it put it at about, where we had Allison, because I did that just by, estimating. And what I want to try to do is figure out where, this solved the equation for me. Okay, this solved the equation for y, so that gives me the value of y. But I'm not sure what that value is. I'm clicking on stuff and I don't see anything. So what I can do is, here's x equals 5. X equals 5. And I can go here and, well, yeah, that doesn't give me an exact value. So, if I really want an exact value, I actually do have to solve this equation here for y and determine what that is. Okay? But I can tell you the answer is near 7.75. And also, once I know y, I can tell you when, because I know how fast she's going. But the other thing you could do is, instead of putting y in here, since you know she's traveling at 10t, you could put 10t in there. And now notice, Desmos doesn't like that at all, so that doesn't work. But I could solve for t and tell you at what time, and I can solve for 10t, and that will give you the position. Okay, so those are some hints on that problem. I went into probably a lot of technology that I suppose I didn't have to, but I think it's good for you to learn the technology and kind of get this idea of what the technology is doing, because as you get better with the technology, I think that also helps you with your mathematics, because the technology is very much based on the graphical language. And so if you kind of figure out how to use that graphical language here in the technology, then I just think that's adding to your mathematics.